Welcome to part 8 of this skimage tutorial. In the previous part, we had just run this particular cell um, and we got this outcome by running the cell. Let's look at the outcome that we got. So what we did was ran a certain functionality on the labeled images, and there are certain regions within the labeled images, and we wanted to find the centroid of each of those regions which are larger than a certain area. So the reason we have to specify that we are after only those regions which are larger than a certain area is because we want to avoid all the small red rectangles which are appearing in the right hand side image here. This is something that we want to get rid of. We want to find the centroid of the coins themselves. So coins themselves are regions, and the way to identify the coins as a region will be saying that pick up that region for finding the centroid only if it is bigger than a certain only if its area is bigger than a certain value. So with that in mind, let's go back and have a look at the code, which is here. So in this line 115, we have fed the black and white image into the label function, which you got from morphology. And what we do here is, let's try to print X shape for X in label image. Let's try to see what it gives us. Okay, so let's not bother too much about the shape of various label images within the black and white image. Uh, and then we went on to show the black and white image. All right, we could as well show the label image instead of the black and white image. But for the purpose of this example, it doesn't matter whether you're really displaying the label image, which basically contains the coins shown in different shades of gray, rather than having same original gray as given in the original image. So if we had used a labeled image, we know what it would have looked like. Basically here too, it would have looked like what we have under this labeled items, with the ones where we have drawn the red rectangles around the regions. Now, having printed the black and white image, we are now going to find out all the regions within the label image. So as you know, we printed in the what we showed in the previous part, we plotted all the regions within the label image, and we drew the rectangles around all those regions. So here again, let's get all the regions by using the region props function. Let's get all the regions within the label image, and then for each of the regions, find the centroid of that region only if the area of that region is bigger than 20 pixels. So if you look at line 129 and 130, this is what it is exactly doing. It's picking up those regions where area is greater than 20, and for those areas, for those regions rather, you find the centroid and identify the coordinates for those centroids in the form of x and y coordinates, and then just do a scatter plot on the same image using those coordinates you have picked up from line 129 and 130, and put a red dot at those coordinates that we have identified in line 129 and 130. So this is how we have managed to get exact good red dot right in the center of each of the points, but wherever we found an area which is greater than 20 pixels, and such areas only those that of coins. All right, so let's go ahead and do one bit more functionality, which is basically converting the labels into different colors. So let's look at the code which is written here, and we are going to execute that right from line 144 till 157. So we want binary image with labels is the variable where we collect an image which has got labels depicted in the form of different colors. So labels are given for regions where pixels are interconnected. So those could be the coins, and there are some smaller regions within the coins themselves which can be identified as independent region in that space. And we want to give a specific color to each of those kind of regions that exist within the label image. So let's go ahead and run these lines of code and see the effect we get. Okay, so as I was mentioning, when we ran the labeled images for the first time, it created an image where each of the regions, which were largely the coins, uh, were shown in different shades of gray. Now we want to go one step ahead where each of those coins, which are the regions, are shown in different colors. So it's far more easy to spot these coins manually. Imagine if you had to do a similar exercise for a microscopic image that comprises of cells, and you want each of the cells to get highlighted in a separate color so that whenever a technician is observing those cells through a microscope, he's easily able to recognize that these are the cells because they appear in different colors, and they can be distinguished very easily. So that's the purpose for which you use this functionality, where you use label to RGB function, feed the label image which has got the regions identified in that, and you see the image that you want to use, on which you want to show the labels in the form of different colors. So we're using label the image as black and white. Label image is the one that carries the labels inside that, and we're using uh, so as I was saying, the label image is the one image which carries the labels. When we say image is equal to BW, which is the second argument within this function call, there's an underlying image that should be used for transforming the labels into different colors. So the black and white image will be used as an underlying image for labeling in different colors. And that's what we did. And as you saw, we can see here the nice effect that we got by converting various labels into different colors. All right, so once again, I'll stop the video here. And there's some more functionalities under SK image which I would like to cover. But I'll come back at a later point of time with some additional videos to cover the remaining functionality in skimage. But for now, I'm going to stop this skimage tutorial here. I hope you enjoyed watching this tutorial as much as I enjoyed making this tutorial. Thanks for watching.